When we start talking about airbag applications, we've got to know the manufacturer's recommendations and guidelines regarding the airbags. The first component of that is knowing the working load capacities of those airbags, what they're designed to lift, what's going to potentially overload them. Airbag systems are designed with blow-offs so that if you exceed the load that the airbag is designed for, you're going to get a purge of excess air or an overloading blow-off of the pneumatic system supplying air to that airbag system. You also need to know the limitations and the design features of the airbag as far as operation or design goes. So with pillow airbags, those type of cushion airbags are designed to typically never be used in more conjunction than two. You're typically always going to make sure that your larger bag is on the bottom, and then there's a progressive way to lift those airbags. When we lift those, you want to ensure that you refer to the manufacturer's guidelines, you're lifting them in the correct sequential order, and you're following the recommendations as far as level of inflation. With the particular airbags that we're going to focus on here today, these are a little bit of a hybrid airbag in that they're not a true pillow type cushion. These airbags are more of a ball type configuration, and then they have rigid components on the top and bottom. The Rescue Tech airbags also have fitting applications in the center points. So you can see in these center components, we have the opportunity or the options to apply threaded elements to these components. The options are as follows. You can either apply caps to these so that they can function as standalone airbag systems. These caps simply seal up the top and bottom of the airbags and make them a contained airbag. When applying these systems, you simply lay them on the bag. You can't cross thread them. Once they're in place, you're going to utilize the tightening wrench, drop it into the T-handle slot, and dial it into position. Once it's fully seated, you can't over tighten it. You'll know when it locks into position. When we flip it over on the other side, you have a couple other variables. You can again apply a cap, just simply sealing the bag off. You can also apply basically a giant piece of all thread. This component is a double threaded entity that allows you to splice one airbag to another airbag, creating a integrous column of pneumatic lifting components that don't have the ability to shift or deviate from that center axis point. Again, same application. Drop in your T-tool and tighten that down until it's fully seated. Once it's in position, you can then take your second airbag and thread it directly down onto this element and then cap off the other component. The last or other application with this is that we put load plates on these airbags. It's important when understanding airbag theory that you understand as the surface area of the airbag in relationship to the object or the load being lifted. As that surface area decreases, thus decreases the lifting capacity of the airbag. So the objective is to maximize that load collection and load distribution from the load to the airbag. Applying a load plate to the top of this airbag enables us to do point lifts without having a small surface area contact that would thus significantly reduce the lifting capacity of the airbag. So if we're in a scenario where we're trying to lift on a direct piece of angle iron or a specific component of the machinery or vehicle, that narrow area contact point becomes a diffuse contact point as soon as we establish a load plate on this airbag. The load plates, you can see, have a smooth surface and then they have a textured surface. This textured surface is specifically designed to integrate with the composite cribbing. So you can see these cutout components in here allow you to orient these cutouts with the nodules that are on the composite cribbing, thus locking this load plate in if used on a bottom side application. This is particularly effective when you're utilizing an articulated box crib base to do an articulated plane lift. So if you have a scenario where you've got a cement mixer or something along those lines where you have a drum or a really unique plane that's hard to capture and effectively lift, you can create that articulating box crib, set this on the bottom side of your airbags, which locks the position of the airbags in place without them sliding down the base box cribbing. It allows you to have that fixed point so that when you do start to lift, you're not going to have the same degree of kick-out potential or of the bag slipping and having to be tethered or harnessed so that they don't slide down the plane. If used on the top surface for that point load lifting application, simply orient that corrugated portion up. Then you're going to grab a hub. This is not a cap like the other component. This is a larger piece with a larger standard bevel on top. We drop that into place, line those up, simply start to spin them, and then again, tighten them down with the T-handle. Now, those are some specific applications for this airbag system in general. But for all of your airbag applications, ensure that before you go into the operating component, while you have an individual setting up your supply with your regulator and your SCBA, or working off your fixed air source with the cascade system, ensure that your actual operating individuals are getting the airbags oriented correctly with the right fittings, and ensuring that they've got the right marriage between large airbags, small airbags, the right configurations, and getting well orchestrated about how we're going to lift those. When you get ready to get your airbags in place, one of the things you want to try and have is a pigtail segment with a control valve. You want to take that pigtail and ensure that that is applied to the airbag itself. When you have that control valve application at the airbag, that allows you to capture the air that is within the airbag, control that by controlling your valve, and then disconnect your supply lines so that you can use them for other pneumatic applications. If you don't have this pigtail with this control valve in place, that negates that opportunity, and unless you have a wide array of pneumatic hoses, there's a possibility that you're going to run out of hose applications for other tool components. It's also important to try and use color-coded systems. So when we're using multiple airbags, you want to use different colored hoses for each airbag so that in the lifting sequence, you can identify clearly which bags you want lifted when and how. So here we've got our pigtail applied to the airbag itself. We're going to set the airbag directly out in front of us to talk about some of the lifting dynamics. We're going to take our hose, apply it to that control valve, ensure initially that that's in the closed position. We can see that we've got our regulator applied to the SCBA cylinder, and before we turn it on and pressurize that system, we're going to get all the other components in place. This is a supply line which is typically going to come out of the regulator so that you can be a little bit remote from the regulator and the supply point when operating the control switch. So there has to be a control mechanism between the supply point and regulator and the pneumatic tool or the pneumatic lifting component, whether it's struts or airbags. These control systems are all pretty much designed the same way in that they have inflation segments and they have deflation segments. They're usually pretty clearly denoted with greens and reds for go or stop or up or down. In this application with this particular control switch, you can see that we had the ability to flow air to two potential sources at the same time. So we want to take our supply component, connect it to the control switch, and then we want to take our supply line that's going to the airbags and connect it to the output side of the control unit. Once all those elements are fully seated, we're then set to engage our SCBA supply point or our cascade supply point and then get our regulated pressure dialed in. On most airbags, you're utilizing typical operating pressures for high pressure airbags around 116 psi. All the airbags are going to have that operating pressure printed right on them, so it's important that you reference it to ensure that you're operating within the safe and designed operating parameters of those airbags. The Rescue Tech airbags are a little bit different. They have some unique operating pressures, and those pressures vary from bag size to bag size, even though they're the same design of bag system. So on this particular airbag, we can see that we have 145 psi max operating pressure. So we're going to take our SCBA cylinder, we're going to turn it on, we're going to then take our regulator, and we're going to dial our regulator up to 145 psi. Once we're at 145 psi, we're set to operate this pneumatic system.